Hello students, Mohan here, lecturer in basic mathematics from Soundarya Composite PU College, and today I am going to discuss one of the important chapters in basic mathematics, that is mathematical logic, which is very important with respect to scoring and in its applications, and also it is one of the essential chapters for many competitive examinations. So before dealing with this particular chapter, let me introduce the marks distribution with respect to your annual examination. From this chapter, you will get one 1-mark question and one 2-mark question and one 5-mark question. So totally 1 plus 2 plus 5, you can fetch 8 marks from this particular chapter, which is very important. So before understanding the concept which is there in mathematical logic, let me give you an introduction about mathematical logic. Mathematical logic, and there is one more name for this particular chapter, that is mathematical reasoning, is a subject which deals with logic concepts or reasoning concepts. Here you people should not much bother about the general sense. You should understand the logic which is there in the question and you have to answer. Therefore it is a mathematical process to arrive at valid conclusion using a certain assumption. You have to use a certain assumption which is there in question, and you should come to a conclusion by using mathematics. So that's about mathematical logic or mathematical reasoning. And mathematical reasoning is one of the subjects or one of the chapters which increase our intellectual capacity. So it will squeeze our brain, it will give exercise to our brain by which we can increase our IQ level. And as I told you, it is one of the most important chapters for many competitive examinations. Now, you can understand these 3 notes by considering an example, that is, observe this particular question which is there in your textbook. This question says you have to find out 2 sentences which are logically equivalent, I mean logically same with respect to the given image. The first option is the door is opened. Yes, obviously the door is open, and the second one is the door is closed. Now the confusion comes whether the door is opened or closed, but observe the third sentence. Third sentence says the door is half opened, and the fourth sentence says the door is half closed. If you ask anybody about this particular image, one of the persons can say that this particular door is half open, and the same person can say that this particular door is half closed, but both the sentences are same logically. Grammatically they are different, but logically they are equivalent. Therefore option 3 and 4, they are equivalent or they are same logically. And don't look at this sentence grammatically. As I told you, you are not supposed to answer a logic question by using general sense. You have to reason it out. And now let's directly come into chapter. The first concept in the chapter is proposition, one of the elaborated concepts. And what is a proposition? Proposition is actually a statement or a sentence which is true or false, but should not be both true or false at the same time. So you can consider any sentence, it should be either true or false, but should not be both true and false at the same time. And I will make you to understand the definition of a proposition by considering some of the examples. And before that, and I have mentioned here that propositions can be denoted by the small letters, so lower cases P, Q, R, etc. And these examples definitely will help us to understand the definition of a proposition. And it is a proposition, it is not a preposition. It is PROPOSITION, proposition. See the first sentence. First sentence says 2 is an even number. Is it a proposition? Definitely it is a proposition, only because 2 is an even number is true. Proposition is a sentence which should be true are false, but should not be both true and false at the same time. Therefore, the first example is a proposition. What about second one? The word logic has 5 vowels in it. Definitely it is a proposition since it is false. We know that the word logic has only 2 vowels, that is O and I, but the statement says that the word logic has 5 vowels in it, which is false. Therefore it is a proposition. And the third one, oxygen is a gas. You students might have studied this in your lower classes. Definitely oxygen is a gas, and this is a true statement, therefore a proposition. And the fourth one is 3 plus 4 equal to 10. We know that 3 plus 4 is equal to 7. Here the question is not to find out what is 3 plus 4. The question is to find out whether the statement 3 plus 4 equal to 10 is a proposition or not. That's what the real essence of this particular chapter. Here we have to reason out and we have to answer the logic question by using the logic sense behind it. 3 plus 4 is equal to 7, but this statement says that 3 plus 4 is equal to 10, which is wrong, which is false. Therefore, definitely this particular statement is a proposition. And the next one, truth value of a proposition. What is a truth value? A proposition will be either true or false. The truthfulness or falsity of a proposition is called as truth value of the proposition. If a proposition is true, it is denoted by, the truth value is denoted by T. If a proposition is false, then the truth value is denoted by F. Therefore, truth value is nothing but the truthfulness or falsity of a given proposition. And you can understand the definition of truth value again by considering an example. So I have considered an example. I have taken P equal to, and one more thing, in this chapter you are supposed to read colon as equal to. You are not supposed to use the symbol equal to. Here P equal to, Bangalore is the capital city of Karnataka. Obviously it is a proposition since it is true. And one more, Q equal to, 2 is an irrational number. The first statement, P equal to Bangalore is the capital city of Karnataka. Since it is true, the truth value is T. And the second one is 2 is an irrational number. Since it is false, the truth value is F. And the next one is, what about these interesting statements which are there in your textbook? The first one is, mathematics is fun. Is this sentence a proposition? Obviously not. Only because for many people mathematics is really easy and mathematics is fun. Many people like mathematics. Mathematics is one of the most easiest subject in this world. In that context, this particular sentence is true. At the same time, there are many people who do not like mathematics. In their context, the same sentence becomes false. Now, the sentence mathematics is fun, both true and false together. Therefore, it is not a proposition only because this sentence is both true and false at the same time. And one more sentence which is not a proposition is, all the people of India like to watch movie. And very importantly, opinion of a person will never be a proposition because opinion has its own drawbacks. Many people will agree certain opinions and many people will disagree to the same opinion. Therefore, opinion will never become a proposition. So all the people of India like to watch movie is an opinion. So therefore, this particular sentence is not a proposition. On other hand, there are many people in India who like to watch movie. In that context, this particular sentence is true. At the same time, there are many people in India who do not like to watch movie. In their context, this particular sentence is not true, it is false. Therefore, this sentence is both true and false at the same time. Therefore, this is definitely not a proposition. And one more interesting sentence from your textbook, that is, tomorrow is Friday. Definitely it is not a proposition, only because tomorrow, the sentence tomorrow is Friday becomes true if today is Thursday. The person who is talking, if he says that tomorrow is Friday, on Thursday this particular sentence is true. But the same sentence becomes false if today is not Thursday. Therefore, the sentence tomorrow is Friday is not a proposition. Actually, don't think of the process when you decide whether the given sentence is a proposition or not. Only because proposition talks about sentence. Proposition is a sentence which is either true or false. Proposition is not a process about which the sentence is talking. And the next one is one more important sentence or statement, and this question has been asked in many competitive examinations in different ways. The question is, after having completed my PUC, I will opt for BCom. After completing my PUC, I will go to BCom. Is it a proposition? And many students say that I may go to BCom or I may not go to BCom. Therefore, it is both true and false. But definitely you are wrong, only because after having completed your PUC, if you people go to BCom, then this sentence becomes true. If you people do not go to BCom, then this sentence becomes false. How come this particular sentence becomes both true and false? This sentence will be either true. I mean, if you go to BCom, this particular sentence is true. If you do not go to BCom, the same sentence becomes false. Therefore, this particular sentence is a proposition, which is very, very important. And the next one is, here there are some of the notes. So the sentences which are not assertive or declarative are not a proposition. So if a sentence is not declarative, if it is not declarating anything, declarative means sentence should declare something positively. If a sentence do not declare anything, then how can I say that the given sentence is whether it is true or false? For example, how are you, what are you, come here. All these sentences are not declarative. And it is very difficult for anybody to say whether those sentences are true or false. Therefore, if a sentence is not assertive or declarative, definitely it is not a proposition. And one more thing, sentences involving question mark, exclamatory symbol are also not propositions, like again, how are you, oh, it's beautiful, how beautiful it is, how old are you, like this. So these questions again, these sentences, once again, they are not declarative, and it's very difficult to deduct their truth values. And one more thing, as I told you, expression of opinion will never become a proposition since it has the both ways. And the next one is, here are some of the examples which are actually not the propositions, and even I will give you the reasons why these sentences are not propositions. The first one is, how are you? How are you is not a proposition. There are two reasons. One is it's not declarative, and one more is it contains a question mark. And one more, hooray, we won the match. Again, there is exclamatory symbol. And again, this particular sentence is not declarative. And the third one is, how old are you? Again, there is question mark. And many students will come with a doubt that if this question is asked, we will get an answer. After having got or after having obtained that particular answer, then the sentence may become true or false. See, once again, let me remind you that, so proposition will not talk about process, rather it will talk about the statement. So only think of this particular statement, how old are you? What can I say about this particular statement, so whether it is true or false. And next one is Sachin Tendulkar is the best batsman of the cricket world. So again, this is not a proposition since it is an opinion. So majority of the people in this world agree to this statement, but there may be many people who disagree. Therefore, this becomes both true and false at the same time. Therefore, even though this sentence is declarative, it is not a proposition. And the last one, which is really interesting, it is very cold here. It is very cold here is declarative. But is it a proposition? Definitely it is not a proposition, only because even though the sentence is declarative, it is not a proposition. The reason is, observe the word here. I have underlined here. It is very cold here means where. So then, without knowing the place, how can I tell you that the given sentence is true or false? If somebody say that it is very cold in Kashmir, I can measure the temperature in Kashmir and I can deduct whether it is true or false. If somebody say that it is very cold in Thar desert, I can measure the temperature and I can deduct whether the given sentence is true or false. Therefore, this particular sentence is not a proposition. So to be more precise, those sentences which involves here, there, so the program was very good there, traffic is very heavy here. So those sentences which involve here, there, words like this are not propositions, even though they are declarative. Now, one more definition, that is logical connector. So you people have come across many sentences which are propositions, and some of the sentences are not propositions. And these sentences are simple sentences. They are single sentences. We can connect these sentences by using, so some of the beautiful words in English, they are and, are, if, then, if and only if. I will explain you the meaning and difference of if and only if and if then together. So by using these words, we can connect two or more simple propositions into one. Therefore, these words like and, are, if, then and if and only if, they are called as logical connectors, since they connect two or more propositions. And again, you can understand logical connectors by using an example. So observe this example. I have taken P equal to 2 is an even number. Definitely it's a proposition and its truth value is T. And one more is 3 is a prime number. Again, it's a proposition since its truth value is F. And these two simple propositions can be connected by using a logical connector, that is and. P and Q. P and Q says 2 is an even number and 3 is a prime number. And here I have connected two propositions into one by using a logical connector, that is and. So like this, you can connect two or more simple propositions by using many logical connectors. For example, I study well is a proposition. I shall score good marks is one more proposition, and these two propositions can be connected like this: if I study well, then I shall score very good marks. So like this, we can connect two or more simple propositions by using these logical connectors, and even these two sentences can be connected by using R also. PRQ. PRQ says 2 is an even number, R 3 is a prime number. So this is about logical connectors. Logical connectors will help us to connect simple propositions into compound proposition. And the next one is definition of compound proposition. I have discussed about logical connectors. By using logical connectors, you can connect two or more simple propositions. And if you connect two or more simple propositions to get a single proposition, the proposition obtained by connecting two or more propositions by using logical connectors like and, are, if, then, etc. is called as compound proposition. See the example: P equal to New Delhi is in India. It's a proposition, definitely, only because it is true. And one more is set of naturals is infinite. Again, it's also a proposition, and the truth value is t. And these two are simple propositions, and by using and, I can connect these two propositions, that is New Delhi is in India and set of naturals are infinite. So the final one, P and Q, is called as, the sentence is called as compound proposition. And here you should not much bother about the connection between New Delhi and natural numbers. That's what I told. So right now, think logically, don't much bother about the general sense. So this is about compound proposition. So compound proposition is very important. There are many ways of connecting simple propositions by using these logical connectors. And the next one is types of compound propositions. Okay students, we have discussed the definition and interpretation of a proposition, and we have understood the definition of propositions even by considering some of the wonderful examples, and even I have explained about the compound proposition. So once again let me tell you, compound proposition is a proposition which is made up of two or more simple propositions by using logical connectors like and, or, if, then, etc. Now let's think of the types of compound propositions. And before moving into types of compound proposition, let me introduce one more definition. So that is negation. What is a negation of a statement? I mean negation of a proposition. So if P is a proposition, then not P is called as negation of P, and which we denote by this symbol. Okay, this symbol, negation P. And observe this example. Here I have taken P. P is 3 is an even number. And negation of P, observe the symbol, you have to use this symbol for negation. Negation of P, according to definition, it should be not 3 is an even number. It's not a mistake mathematically, but let's be more legible grammatically. Understood? Therefore, the best way to negate the proposition 3 is an even number is 3 is not an even number. That means you have to negate the given proposition by using the word not, which is one more logical connector. For example, Mysore belongs to Karnataka. If you want to negate that particular sentence, you have to use not. Not Mysore belongs to Karnataka. Mathematically it's okay, but grammatically the best or the perfect way is Mysore doesn't belong to Karnataka. So therefore, while negating, you have to use the word not properly, and there should be legibility in grammar. So now let's concentrate on truth value or a truth table of negation. Now before that, what's the idea behind negation? So if P is any statement or proposition, not P is actually called as negation. So therefore here the idea of negation is to reverse the truth value. So if the given proposition is T, then if you explain the same proposition by using not, immediately the truth value T becomes false, obviously, and the truth value false become T, I mean true. Since we use not, observe this example once again. 3 is an even number. Obviously it is wrong, I mean it is false. Its truth value is F. But observe negation P, 3 is not an even number. Obviously it is right. Now its truth value is T. Therefore, truth value which was F is converted into truth value which is T by using negation. Therefore, the main idea of negation or negating the propositions is to convert truth value from true to false and false to truth. Once again let me tell you, negation means you have to use the logical connector, that is not. Okay, and now let's come to the types of compound proposition. The first one is conjunction. As I told you, compound proposition is connection of simple propositions by using the logical connectors, and or if then there are many logical connectors. And for your syllabus there are 4 logical connectors, therefore there are 4 types. The first one is conjunction. In conjunction, we combine 2 or more propositions by using the logical connector AND. The compound proposition obtained by using a logical connector AND is called as conjunction. And even I have taken an example. And before that, just observe this note. This note says if P and Q are any 2 propositions, then conjunction is denoted by this particular symbol. We have to pronounce this particular symbol as AND only. Logically we call this particular symbol as and this should be read as P and Q. And now just observe the example. I have taken P equal to E is an oval and Q equal to 3 plus 4 equal to 7. These 2 are simple propositions, obviously you know. And I want to connect these 2 propositions by using the logical connector and the symbol is P. Never forget, you have to read it as P and Q. P and Q equal to E is an oval and 3 plus 4 equal to 7. Here I have connected these 2 simple propositions by using a logical connector and I got a compound proposition. This compound proposition is called as conjunction since I am using the logical word AND. Now let's come to truth table of compound proposition, that is conjunction. In conjunction, and before that let me tell you one thing, never forget AND binds. A and B should come to staff room. Means that sentence becomes true if both comes to staff room. Therefore T equal to T. I mean here if you take A, here if you take B, A and B should come to staff room and this becomes true if both will go to staff room. Therefore in conjunction, in truth table, so if both P and Q are true, then only conjunction is true. In all other cases it is false. So one of the best ways to remember this particular truth table is this. This is how I remember the truth table of conjunction. Here A and B should come to staff room. Remember this particular sentence. Here A goes, B goes, therefore right. True, true, true. A goes but B doesn't, therefore wrong. Question is A and B should come to staff room. A binds both A and B. Both of them should come to staff room. Here A comes but not B, therefore P and Q, A and B should come to staff room is false. And again A doesn't go, B goes, again wrong. And one more, A doesn't and B doesn't, again wrong. Since AND binds both the sentences, therefore the truth table for AND is true if both are true. Once again, A and B should come to staff room. True. A and B, true. A but not B, false. Not A but B, false. Not B and not A, false. Therefore this is one of the best ways to remember truth table for conjunction, only because to do further problems, especially for that 5-mark question, you need to remember these tables. So if you forget these tables, it is not at all possible for you students to proceed. Therefore learn thoroughly and be careful about a table. So yes, and the next type is disjunction. As the name suggests, disjunction means the compound proposition obtained by using the logical connector or. If P and Q are any two simple proposition, then obtaining a compound proposition by using R is called as disjunction. For example, so before going to example, once again let me go through this note. This note says if P and Q are any two propositions, then disjunction is denoted by P. Observe this symbol Q. Again, in logic mathematics, this symbol is called as R symbol. And once again, this should be read as PRQ. And you can better understand disjunction by using this example, and observe this example. There are two simple propositions which I have considered. The first one is cow is black, P equal to. Second one, Q equal to milk is white. These two are simple propositions, and I have connected these two propositions by using the logical connector R, that is PRQ. Read it as PRQ. PRQ equal to cow is black or milk is white. And here two propositions have been combined to make one proposition by using R, that is a compound proposition which is known as disjunction. So once again, disjunction is a compound proposition which is made up of by using the logical connector R. Have you understood? I do hope you have understood disjunction. In conjunction we use AND to combine. In disjunction we use R to combine. That's the difference. And now let's come to truth table. As I told you, in conjunction, truth table should be remembered properly, so for the future studies. So observe the truth table for disjunction. In disjunction, for truth table, if both are true, disjunction is true. If one is true, one more is false, like these two, again they are true. If both are false, then it is false. Once again, how to remember the table for disjunction? Again, the best way which I follow is the same thing. A and B should come to staff room for conjunction. For disjunction, A or B should come to staff room. Now the question is, A or B should come to staff room. A comes. So before that, let me start from row number 2 only with respect to truth values. Here A comes but not B. No problem. A or B should come. Therefore it is true. And here not A, I mean A doesn't go but B goes. Again it is true. No problem, because A or B should come. And observe the third one. A doesn't go and B doesn't go. If both doesn't go, definitely it is wrong. Only because either A or B should go to staff room. If both doesn't, then it is false. Now let's come to the first one. A goes and B goes. Here actually A or B. If both goes into staff room, it's not a mistake. We have asked either A or B should come. If both goes to staff room, it's not a mistake, it is true. Okay, whomsoever we want, we can call them, or the other person can be sent out, or both the people can remain in the staff room. Therefore, see, try to remember this particular table like this. A or B. A and B is true. A but not B, again true. Again A goes, A doesn't go, B goes, true. Here A doesn't go or B doesn't go, it is false. This is one of the best ways to remember the truth table for disjunction. And one more way to remember disjunction is true always, except in one case. If both are false, then it is false. In all other case, disjunction is true. And as I told you, remember this table very well, and you will understand the importance of this table. And I do hope you people have understood disjunction. Once again, disjunction is a compound proposition in which we use R. Now, let me come to one more types of the compound proposition, that is implication. There is one more word for implication, that is conditional. Even you can call it as conditional. Implication is very, very important and not difficult to understand, but a little bit different. So if P and Q are the compound proposition obtained by using the logical connector if then is called as implication. And again, let's go to note. Note says if P and Q are any two propositions, then implication or conditional is denoted by P arrow mark Q. Observe this denotion very carefully. Again, you have to read it as P implies Q. And before going into example, let me tell you one thing here. In P implies Q, what is important means Q is important. P should imply Q. Finally, Q should be implied. It is actually should be from P. Sometimes even if it is not from P, if it is, if Q is implied, then the work is done. Okay, I will make you to understand this by considering the table and observe this example. I have taken P. I have considered two propositions as usual. The first one P. P says the triangle is equilateral, a proposition, and Q says all the sides of triangle are equal. These are two simple propositions, and these two propositions can be connected by using the logical connector if then. And P implies Q, in which we use if then. Observe, if the triangle is equilateral, then all the sides are equal. P is the triangle is equilateral, Q is all the sides are the triangle are equal, and P implies Q. This should be read as if P then Q. If the triangle is equilateral, then all the sides are equal. Therefore, connecting two propositions by using if then is called as implication. Now, the truth value for implication. The truth value for implication is not at all difficult, but as I told you, it is little bit different. See, if both are true, it is true. If P is true and Q is false, it's false. If P is false, observe this particular row very carefully. This is one of the confusions to many of the students. If P is false and Q is true, but implication is true. And finally, if both are false, then also it is true. And unlike the conjunction and disjunction, the truth table for implication looks a little bit different. In conjunction and disjunction, you can easily remember table in many ways. By using A and B or A or B. And how to remember the table for implication. First, let me tell you how to remember the table for implication. Then later I will explain you how this particular column is obtained. The best way to remember is take this as question, this as passing of the examination. If questions are easy, then I pass the examination. Is it not true? True. If questions are easy, then I can pass examination. True. If questions are easy, then I cannot pass examination. Obviously, no one will agree. It's false. And observe this very carefully. Questions were not easy, but I passed examination. Again, this is true. Only because in P implies Q, what is important is Q. We have to imply Q. So one of the best examples is, if I go to Mysore, then I can see palace. Here what is important is not going to Mysore. The important one is seeing palace. See, if I go to Mysore, then I can see palace. True. If I go to Mysore, then I cannot see palace. False, obviously. I didn't go to Mysore, but I saw palace through some other media. Here finally what is important means seeing the palace. Here I didn't go to Mysore, but I saw palace through some other media. Therefore finally my aim was to see the palace, therefore I saw the palace. It's true. And finally the last one is observe. Let me come to that question and examination. This is questions were not easy and I didn't pass examination. Again it is true. Once again, questions were easy. I mean, if questions were easy, then I pass examination. True. If questions are easy, then I will not pass examination. False. If questions are not easy, then I passed examination. Again true. Here questions are not easy and I didn't pass examination. Again it is true. And once again, this is the best way to remember truth table for implication. So no confusion with respect to row number 3, only because as I told you, implication is very important, and in implication we have to concentrate more on Q. P implies Q. Finally at the end what is important is Q. Q should be implied somehow. Here actually even though P is not there, or even though P is false, Q is implied. As I told you, I didn't go to Mysore, but I saw palace, and my aim is successful here, and this is true. And these are the types of the compound propositions. And thank you all